Hey guys, welcome to this video. So in this video, I'll give you a quick tour of my popular science book on physics, which I published in 2022, the revised edition. So a lot of my friends has been asking. So this is just a quick tour of the book. So this is the paperback. Our Physics So Far Revised Edition: A Journey Through Spacetime, Consciousness, and the Fundamental Nature of Reality by Arpande. So yeah, dedicated to my beautiful parents with love and respect. So this is my contents page, you can see. Oh, and in case you were wondering, I'm right now on the roof, and this thing is the moon. The thing that you can see behind me, it's the moon. Many of you would have guessed, but anyway. So just thought of mentioning because this my first when I thought of writing the book, one of the first incidents, one of the first lines that came to my mind was Einstein's claim, Einstein's famous line that, "Do you really think that the moon does not exist when I'm not looking at it?" And through this, he wanted to highlight this the quantum mechanical tension between realism and locality, and this Bell's inequality, because Einstein refused to accept quantum mechanics, some aspects of quantum mechanics, and very rightly so. Even today, after 100 years of quantum mechanics first being formulated, it's not a complete theory, and there are a lot of foundational quantum mechanical questions that we do not have an answer to yet. So anyway, this is the contents page. First, we start off with a preface to the updated edition. So this is the updated edition, and then there is a prologue, introduction, my story so far. So you see, there is the introduction is my story so far. So here I basically start off with my story, and my story means up to 2022, because this book was published then. A lot has changed in my life since 2022, but that is not included in the book, obviously. So anyway, in the introduction, I try to justify my decision of writing a book when I was still only 16 years old, and I also very briefly mention my own story. That's why it's introduction, my story so far. Then we have conclusion, is our story so far. So the theme of the book is that we go through the major developments in the history of physics, and along with that, some other, in general, the quest for knowledge. It's not specifically physics; it's also more than physics. And so we start off with my story, and then we look at this story, and this is our story. This is the story of humankind, the story of all of us, our quest to understand the fundamental nature of reality. And then finally, we conclude with our story so far. And throughout this introduction and conclusion, this theme of so far is very prominent, because this book only tells you what we know so far. And the importance of these two words, so far, is that this is our physics so far. There's a lot more to come in the future, and maybe one of you who are reading the books, or regardless of whether you're reading the book or not, maybe some of you will be the ones to take forward this story through leaps and bounds, right? And maybe write the next chapter in physics, because there's a lot still that we still do not understand. So it's the story so far. It's not the complete story yet. So in the part one, we talk about cosmology and the Big Bang, and then the journey of physics begins. So basically, some very basic ideas about Newtonian cosmology, the Big Bang, dark matter, dark energy. Very basic, because this is a popular science book, right? Nothing technical. And then the journey of physics begins. Here we just look at the classical physics, Newton's physics and electromagnetic theory, and mathematics, how mathematics helped physics. The classical, the beginnings. Part 2 is about relativity. So what's so special about special relativity, and then the general theory of relativity. Part 3 is about the quantum revolution, quantum mechanics. You see, I have devoted 4 chapters to this. The atom and its structure, uncertainties deep down, what is quantum mechanics, interpretations of QM. Part 4 is about the physics revolution that followed after quantum mechanics. That's mainly particle physics and the quest for a theory of everything. So Bézier bosons, quirky quarks, and leaping leptons. As you can understand, this chapter is all about particle physics. Then we have the information paradox. So since this is a paradox that arises when we try to merge quantum mechanics and gravity, so that's why I decided to devote an entire chapter to the information paradox. And I've also discussed some interesting ideas like entropic gravity in the same chapter. And then we talk about the theory of everything so far. What is the quest? What are the candidate theories like string theory, loop quantum gravity, and the usual. Part 5 is about chaos theory and fractals, an entirely different kind of science from whatever we've been discussing so far. But again, this is physics, and the chaos theory is also it's a very important theory if you want to understand nature. and it's very different in flavor from whatever we've been discussing so far. That's why this is a different part, different chapter. Part 6 is about consciousness. We try to understand consciousness scientifically, uh, and we discuss some theories of consciousness and also some basic popular science level neuroscience and stuff beyond the brain. And finally, the last part is about metaphysics. It's on the fundamental nature of reality. So here we address the question of what metaphysics has got to say about the nature of reality, because so far we devoted so many chapters to what science has got to say, but ultimately this book is about our quest for truth. And I mean, it's open to question, and personally I think science can take us closer to truth than metaphysics. But I mean, why not discuss metaphysics, since it can also give us some very good insights. So that's why the last chapter is devoted to metaphysics and this kind of philosophical arguments about the fundamental nature of reality. Then there is conclusion, our story so far. Then we have an epilogue, and finally, yeah, we have the acknowledgement, suggested reading, and about the author, whatever. This is the preface to the updated edition. See, in the prologue, I just this is a kind of interesting. I think I'll just read out the prologue and epilogue, because this is very interesting, since I'm anyway making like a virtual tour of the book. So James enters the room exhausted and sits down at his desk. Alexa, he calls out to his wife. It seems more and more pointless by the day. The Amazon Echo Dot lights up. So if you have an Amazon Alexa, and if it's connected, I mean if it's switched on, if you say Alexa, it will light up. So James angrily switches it off. What's the matter? Asks Alexa quizzically. Well, I have been thinking about it all lately, all the recent discoveries and stuff. It seems the universe is just a temporary, metastable state. We started off with nothing, and nothing will be left in the end. All these theories, equations, and stuff are meaningless anyway. They are not eternal. So this is a kind of, there's some existential dread in this whatever James is saying. Beyond the science and everything, there is this dread that everything is transient, everything is temporary, nothing is eternal. But then Alexa, I mean James's wife, not the Amazon Echo Dot. This is a very interesting point. But she says that it's all these theories and equations that are telling us that nothing will be left in the end. So if they are meaningless according to you, then can their predictions be trusted? This is again a very important and kind of, this question again has got a philosophical twist to it. I don't know, it seems like we are running in circles. What's the point of it all? We still don't know whether a theory of everything is possible at all. There have been quite a few instances throughout history when we thought we were closing in on the ultimate truth, but not so fast. Will we ever discover a final theory? So yeah, you might remember Albert Michelson once said at the dawn of the 20th century, before quantum mechanics and relativity, he said that essentially all of physics was discovered. All that remains is to find the sixth decimal place, I mean more accuracy. But now we know that he was mistaken. Quantum theory, group relativity, and even today, there are so many questions we cannot answer. So there have been quite a few instances throughout history when we thought we were closing in on the ultimate truth, but not so fast. That's true. My dear James, even though we haven't discovered a final theory yet, you cannot deny that we have discovered a lot of interesting and important stuff. And then James says that, well, what's the point of discovering this and that piece of isolated knowledge unless we can knit it together into a single unified theory? So my very existence seems pointless to me if I don't know why I exist. This is very true, because I don't know if it's to what extent it's relatable to you guys. But personally, if when I'm asked like why did I decide to study physics, many people would say that because they are curious, they find physics interesting. For me, it's not merely a curiosity, and not just because I find it interesting. It's like it's like haunting. If I don't do physics and these questions, what is why, how did the universe come into being? What is consciousness? How do complex systems behave? These questions will keep on haunting me. So doing physics is the only way. It's not an option. I mean, it's the only option to me. If you know what I'm talking about, it's the only option to me. It's the only option to me. So that's what James is saying here actually. My very existence seems pointless to me if I don't know why I exist. Now, maybe I will never know why I exist, but at least if I'm trying to find out why I exist by doing research and everything, at least I'm trying to justify my existence. Things become more acceptable to me. It's kind of a coping mechanism. It's not just because I find it interesting. Then, well, to me, there isn't any point to existence, Alexa is saying. But that shouldn't make you sad. We should try to uncover the secrets of the universe and at the same time enjoy our lives. Science has taken us a long way forward, and you never know, this time we may really be closing in on the ultimate truth. There are hopeful signs. But there's no getting around the fact that we are all going to die one day. Even if we do discover the ultimate truth, what does it mean for me individually? Will it let me live forever? So again, this existential dread is very prominent in James, whatever James is saying. Well, James, do you do science for personal gain? Of course not. We all have to play our part and help write the story. The story might mean nothing to us individually. Meaning in life is something we need to find for ourselves. Haven't you and I vowed to explore science as long as we're alive? Haven't we agreed that the meaning of our lives is just one thing, science? Of course we have, Alexa. I sometimes get a bit, well, you know what I mean, but of course you were right. As scientists, we will keep exploring science at the technical level, but I think it's also important to step back and look at the big picture, to recollect the story so far, what we have discovered and what we have learned. Let's look at the story once more, so that the next time our children ask us to tell a story, we can tell them the greatest story ever written. You're right, James, let's do it. So this sets the tone for the next few chapters, for the entire book actually. This is a prologue. And let me just quickly show you the epilogue as well. And then I'll show you a quick tour of the book. Of course, I'll not be reading out each and every page. And then that's that, yeah, epilogue. So after we have looked at the entire story, our story so far, then again, let's come back to James and Alexa. The story is fascinating, no doubt, but I have a couple of questions, says Jack. So Jack is a kid. So James and Alexa are like one of their children. And Jenny is also another of the children, right? Just for context. So the story is fascinating, no doubt, but I have a couple of questions, says Jack. Now that Alexa and James, so they decided to tell this story to their kids, right? So that the next time our children ask us to tell a story, we can tell them the greatest story ever written. So that is what they're doing essentially through the entire book. Although within the chapters, I've not used these characters, I've not used the name like James or Alexa, but that is the idea basically. Just adds a creative touch to the book. Okay, and finally here's the epilogue. Just a second. So Jack says that the story is fascinating, but I have a couple of questions. If we have been able to discover so much about our universe, it seems to me that God wanted us to discover all this stuff. If he would have chosen to keep it secret, we wouldn't have come so far. Or it may be the case, pipes in Jenny, who has always been of the more philosophical type, that all that we have discovered is just an illusion. We can never know the true nature of reality. Well, Jack and Jenny, says James, what both of you say are important points. But Jenny, we cannot stop doing science just because all of it might be an illusion. I didn't say that, Dad, says Jenny indignantly. I and Jack want to be scientists and not philosophers. All I said is that we cannot rule out that possibility that it is an illusion. That's true, nods Alexa. As for what you said, Jack, I would say it need not be true. Jack said that if we have been able to discover so much about our universe, it seems to me God wanted us to discover all this stuff. So Alexa thinks now it need not be true. Thoughts and experiments can uncover the nature of reality. It doesn't mean God wants us to discover the fundamental nature of reality. I doubt the very existence of God. Well, Mom, says Jack, I see what Dad means when he says you're unromantic. Yes, Alexa is hard and cold, scientific, smiles James. She hates philosophizing about stuff like God, and I respect her attitude as a scientist, even though I find myself drawn to the metaphysical aspects. I'm just showing the different personalities of James and Alexa and their kids. But the point is, all of them are unified by science. So it need not be. So science means we are all unified in our journey of finding the truth. But that doesn't mean that all of us have to be of the same type. Many scientists, all scientists are different from every other scientist. Right? That's what I wanted to highlight through this epilogue, actually. So you said you had a couple of questions, Jack, says Alexa, smiling to herself. What's the next question? Well, I want to be a scientist and I'm more inspired after listening to our story so far. But I was wondering if I would make a good scientist. That's something I've been wondering as well, adds Jenny. Well, you need some serious training to become a scientist. It's not easy. You have to be curious as well as skeptical. You have to be good at spotting potential connections, generalizing concepts, handling equations, thinking radically and stuff like that. But I believe, and I think your mom will agree, that you can do anything you're determined about, as long as you're patient and hardworking. I completely agree, says Alexa. 3 cheers for science, shouts Jack and Jenny. Their parents join in. Hip, hip, hooray. The 4 of them hug one another, all united by the same passion, science. Okay, so let's just quickly go through see, this is the introduction, my story so far. I'll just quickly, of course, I'll not be reading everything. So, yeah. Part 1 is Cosmo and Classical Physics. This is Chapter 1, Cosmology and the Big Bang. So we start off with some beautiful and relevant quotes for every chapter, and then I'll just give a quick tour. See, the very big and the very small, Olber's paradox, why is the sky dark, Newton's genius, the moon and the apple. So these are very fundamental questions, but very simply I've explained it without going into the technicality, because this is a popular science book. Bentley's paradox, cosmology, the cosmos under investigation. Then we have starts with the bang. Of course, I've talked about the Big Bang here. The Big Bang and the 4 forces, asymmetric and older than it seems. Here I've talked about barrier and asymmetry and the age of the universe. Then is the universe fine-tuned for life, aliens and all this stuff, and then how will the universe end, dark matter and dark energy, and all. Maybe I'm going a bit too fast. The journey of physics begins. Again, we start off with physics and mathematics. So in this chapter, I've mainly discussed about classical physics. First, I've discussed about the difference between the physics and mathematics, the physics approach and the mathematics approach. Then we the laws of motion, Lagrangian mechanics, gravitation, uh, electromagnetism, and just classical physics in general, right? As you can see, and then we end with black body radiation, which, like, lay the that was the starting point of quantum mechanics. But then before we move to quantum mechanics, we first take a detour. We discuss relativity in part 2. So we start off with special relativity. As you can see, what's so special about special relativity. So first we talk about space dimensions from a very basic point. All of these ideas have been explored. So I have not assumed that my readers are physics students or physicists, of course. So what's special relativity all about? Lorentz transformations. I mean, then some interesting illustrations that show all of this, that explain the relativistic assumptions, and I mean that explain these concepts like length contraction, time dilation, mass energy equivalence, and everything. And then all of this I've discussed, causality and this. See, this is the simultaneity and everything. Then we talk about the general theory of relativity, which is the theory of gravity, the best theory of gravity that we currently have, of course. See, we are talking about the sun and the earth, and maybe we could also talk about the earth and the moon, and you can just see the moon above me. So this moon is very important in physics, because this when Newton looked at the moon, he was like, okay, maybe the moon is also constantly falling relative to the earth, just like an apple falls to the earth, and that's how he thought about gravity. You see, this has been discussed also, I think, in my book itself. Since I mentioned this, let me just show you this figure. It should be here somewhere, if I'm not much yeah. So Newton said that if I just throw a stone, it will fall back to the earth. But if I throw it with enough velocity, it will start orbiting. And I mean, yeah. So in this chapter, we discuss general relativity, Einstein's new theory of gravity. We discuss this bending of light and equivalence principle, Einstein's field equations, curvature, and some illustrations, some black, and we also discuss black holes and etc. White holes, wormholes, generativity, incomplete, everything. Now this is part 3, quantum mechanics. So we start with the atom and its structure, atomic spectra, some very basic early indications of that we need a new theory beyond classical physics. Apart from blackbody radiation, we also have this spectra, I see. Continuous emission and absorption spectra, earlier models of the atom, Bohr's atomic model, very like layman level discussion, popular science level discussion, obviously, as I keep saying. The next chapter is uncertainties deep down. Here we mainly discuss like the de Broglie's idea, wave particle duality, the double slit experiment using electrons, and finally Heisenberg's uncertainty principle, obviously, the uncertainty in quantum mechanics, quantization of angular momentum, and then something else as well. I'm not going over every subheading actually. This chapter is about the quantum mechanics, the formulation of quantum mechanics, the canonical formulation. I have like very basic idea, like quantum tunneling, the wave function. What is the wave function? Then Schrodinger's equation, Schrodinger's wave equation, and then we have relativistic quantum mechanics, the basic idea, Dirac's equation, Klein-Gordon equation, antimatter, quantum mechanical model of the atom, and then some applications of quantum mechanics like semiconductors, superconductors, and quantum computers. And finally, here we just give you the very basic rough idea of path integrals, because path integral I cannot discuss mathematically. It's a popular science book, and at the time of writing the book, even I myself was not aware of the mathematics of path integral. But in my undergraduate course, in my bachelor degree, for my bachelor's dissertation, I explored path integrals. But that came only later. In 2022, even I was not an expert on path integrals. Even today, I'm not an expert, but at least now I understand the idea, mathematically I understand the theory, the path integral formulation, but then I did not. Now this is interpretations of quantum mechanics. Here we discuss Bell's inequality, locality, and realism, like EPR paradox and everything. Using a simple illustration, Bell's inequality, Einstein's battle against quantum mechanics, and then we discuss Schrodinger's cat. Some philosophical, like the interpretations of quantum mechanics basically. Why large objects cannot exist in superposition, what does QM tells us about God, quantum Zeno effect, interpretations of QM, like we talk about Copenhagen interpretation, many worlds interpretation, and etc. Part 4 is physics today. So start off with particle physics, like bizarre bosons, quirky quarks, and leaping leptons. Start off with forces, virtual photons, pair production, particles as vibrations in a field. The basic idea of quantum field theory in a qualitative manner without going into the technical equations and everything. Vacuum catastrophe, then bosons and fermions and everything. The standard model, strong and weak nuclear forces, gravitons, mass. Mass means basically I've discussed the Higgs field, the Higgs boson here. Why Higgs boson, metastable, detecting the Higgs boson and other elementary particles and everything. This chapter is entirely devoted to the concept of the information paradox, to the idea of the information paradox, black hole information paradox. So we start with thermodynamics and we discuss entropy at a very basic, very briefly. You see entropy, second law of thermodynamics and everything. And then Boltzmann's hypothesis. We also discuss time, just laying the groundwork for this, for moving on to the black hole information paradox. Yeah. And then we discuss entropy and information, and finally we move on to the black hole information paradox, possible solutions, holographic principle, entropy, gravity, and these things. What about the theory of everything? Okay, this is a very interesting chapter. So here we discuss the this philosophy of unification in physics, and then we start off with the quantum revolution once more, the four forces once more. Then this Kaluza-Klein theory, the idea of extra dimensions, and this we have discussed. Then we discuss string theory, a candidate for a final theory. We also then briefly discuss, I think, loop quantum gravity. Yeah, loop quantum gravity, and then we discuss, problems with these theories. And then here's the interview with Edward Witten. I interviewed renowned physicist Edward Witten. Who is one of the his contributions to mathematical physics and quantum gravity research, string theory, it's like groundbreaking. So this interview is also published in the book. And I end off with some concluding remarks in this chapter. Then part 5 is chaos theory. I already told you, I showed you the content. So chaos theory and fractals, we focus on this chaos theory and fractals, nonlinear dynamics. This is an entirely new science, so that is what we discuss in this chapter in very basic level, elementary level. So chaos and animal population, the Mandelbrot set, the butterfly effect and sensitivity toward initial conditions, chaos and weather prediction, turbulence and strange attractors, mode locking or entrainment, Sierpinski triangle, Cox snowflakes, some different fractals, chaos and medicine, some applications of chaos theory, fractals and psychology, 2 misconceptions about chaos and fractals. Then this is about consciousness, part 6, beyond the brain, as you can see. So yeah, what is consciousness? We discuss from a scientific as well as philosophical perspective actually, and we discuss some possible interpretations, because we don't know what is consciousness. Nobody knows. Nobody has the answer, and maybe we never will, but anyway. So what is consciousness? It's a very long discussion. What about free will? As you can see the subheadings, the birth of brain, and here then I move on to neuroscience a bit. This is science, neuroscience, the birth of brain science, the brain, dreaming, then evolution, models of the human consciousness. This is the symbolic model, and we also discuss evolution and emotions, and some other interesting ideas like game theory, decision making and game theory, life as a game. Very simple idea, but I mean at a very simple level. How to deduce like Sherlock Holmes. A very interesting addition to the chapter. But this is about how humans make deductions. But I have also used a lot of inputs from the Sherlock Holmes adventures, because I was very obsessed with Sherlock Holmes during that point. So I even published a Sherlock Holmes adventure, my own story, kind of a fan fiction. You can check it out if you want. The Adventure of the Injured Cabman. You'll get it on my website or anywhere else on the internet. So yeah, how to deduce like Sherlock Holmes. And yeah, I think this goes on for a few pages. I give some illustrations also for how to have the right intuitions. By deduction, and I don't only mean like criminal deductions, like deductions about a crime. It's in general, because in a way scientists are also like detectives. They are trying to investigate this universe, right? So it's also kind of detective. Artificial intelligence, immortality, and then we end off with some concluding remarks, the future of neuroscience, and blah blah blah. Part 7 is metaphysics and science, okay, on the fundamental nature of reality. So here we discuss a lot of metaphysical arguments. You see this the idea of oneness, particulars and properties, what is possible and what is not, what is nothingness. Now these are all very fundamental level ideas. I've not these ideas, I mean, I've not used any, there are no assumptions or any scientific assumptions in these arguments. Paradoxes, Russell's paradox, the Raven paradox. What are paradoxes telling us about the fundamental nature of reality? Is physics better than metaphysics? 2 problems with scientific research. How much can we know? What we cannot keep why we cannot keep the big picture in mind? And aside on God and Einstein's belief in God. And I think with this we end this chapter. Yeah. So finally, then we have conclusion our story so far. This is also very interesting. Here I make some general comments about the future of humanity, the future of science. It's conclusion. It's not as in it's not the conclusion of everything we have discussed in the book. It's no point. It's not possible to conclude everything we have discussed in this book. It's over 360 pages. You can see 319. So not that, but I just use the conclusion to discuss about some of my speculations about the future of humanity and the future of science in general. So is science going to end? As you can see, this science going to end. You can get an idea about what we have discussed in the conclusion. Does God play dice? What's the meaning of life? Like some very broad general questions. Is life meaningless? And finally, I think, what's the point? Yeah, what's the point? And with that, we have. So yeah, this is what I have like finished the book with. This is the kind of the ending line. And this is very relevant, all lives are different. This is a quote from Sean Carroll's book, The Big Picture. All lives are different and some face hardships that others will never know. But we all share the same universe, the same laws of nature, and the same fundamental task of creating meaning and of mattering for ourselves and those around us in the brief amount of time we have in the world. 3 billion heartbeats the clock is ticking. So at times it indeed seems that there is no point to anything and nothing really matters in the end. Perhaps it's impossible for us to answer the big questions, but of course, it cannot be denied that we would definitely discover a lot of interesting stuff along the way, which will directly or indirectly affect our lives. Mostly, I believe, for the better. And we have already discovered a lot of amazing stuff. Of course, we only have about 3 billion heartbeats. We won't live forever, and that's final. But we shouldn't be selfish and care just about our personal existence. We should also care about humanity and science as a whole. And the fact that we have only 3 billion heartbeats should, in my opinion, strengthen our urge to spend our finite lives as happily and meaningfully as possible. We have a limited amount of time, and we should make the best use of it by taking part in the journey of discovering the fundamental secrets of nature. Of course, this is not a compulsion. You're free to live life your own way without bothering with the big questions, as long as you don't do anything unethical. And if ever the question of what is the point of taking part in this journey confronts you, then remind yourself that the journey is always much more enjoyable than reaching the destination, provided there is a destination at all. But there can very well be one. The story so far has been highly enjoyable, insightful, and useful to us. There is so much more to know, to discover, to deduce. We cannot afford to lose any more time. Let's let the story continue. Let's move on. So we end the book with a very, like, kind of a call for action. Let's move on. And then there's the epilogue. I already showed you, and then acknowledgements. Finally, suggested reading and about the author. And I think that that's the end of my book. So basically, this book now, when I look at the book, when I read the book, of course I don't read the book now. I don't have the time, and I mean, what's the need? Why should I read a book that I wrote 5 years ago? I think it's actually 5 years ago. I started writing the book more than 5 years ago. So when I read the book, I find that maybe I could have done it in a better way, and maybe I have plans of launching a third edition. This is actually second edition, revised edition. But in the future, because of course in the last 3 years of my undergraduate degree, I've learned a lot. I've learned a lot, and when I was writing this book, admittedly I was very young and I was not that much knowledgeable in physics and everything whatever I've discussed. But still, overall I do not regret my decision of writing this book, because the way I used to think about all these big questions when I was only 15 years or 16 years old, that is kind of documented in this book. This book is not perfect. I think no book is perfect, but this book is even less perfect because it was written by someone who is not experienced, not qualified. But I still believe, like I say in some of my previous videos, I also said this. I still believe that if I were to write, if I were to say that, okay, let me wait, let me not publish the book right now, let me wait until I have a PhD and everything, then then through these years of academic training and formal training, conventional training, my urge to write a book of this magnitude and write about my ideas, not only about physics but in general, I think this would be lost. So your ideas, your dreams, they're like just like human babies. So if you have a baby and if you say that, okay, I don't have the money to feed my baby, so let me just leave my baby as it is, and let me just first let me take a break maybe for 5 years, and in these 5 years I will do some good job, I will make a lot of money, and when I have a lot of money, when I'm established, after 5 years, once I'm established, I will come back to my baby and take care of it. Then if you don't take care of the baby in those 5 years, it will die. Same for your ideas and dreams. If you say, okay, I have a dream of publishing a book, but I'm only 16 years old, so maybe I should wait until I am established in life, until I have a PhD and all. If I did that mistake, then when the time would come when I actually have a PhD and everything, my interest, my dreams would have died. No, my urge of writing a book would no longer be present. That's what I believe. So anyway, I gave you a virtual quick tour of the book. I hope you liked the video, since some of you were asking of it. If you want, you can purchase the book. But yeah, anyway, if I would say that you just purchase the book only if you are really passionate about these questions, and if you are a layman. I mean, if you're not a physicist or a physics student, because if you're a physics student, there is very little you can learn from the book, because it's for the general audience. But still, I would say, I'm not promoting my book, but still I would say that even for a physics student or even a physicist, some arguments, and especially some philosophical arguments, and some that might be an interesting read for you. But yeah, this book is meant for those people who want to understand the approach of physics, whatever we have done so far, the history of physics, and what lies in the future. It's for them, but they don't know the technical details yet. This book is actually for that kind of audience. This book has been written keeping them in mind. So yeah. And by the way, if you have read the book, you can just comment below if you want to leave a review. If you can also leave a review on Amazon. That would be very good. I'll give the link to buy the book in the description. So yeah, I'd like to know your comments. Thank you so much, guys, for watching the video.